My name is Nicole, and I'm really excited to be able to tell you guys a little bit about what I do and what it means to be an astrophysicist, which I think is super exciting. So hopefully, yeah, you guys will enjoy it. And I really loved all your questions that you shared in the registration form. I probably can't get to all of them in my talk because there were so many good ones. So please feel free to ask them in the chat or after I'm done talking, and I'll be happy to talk more about anything. So just to introduce myself, I'm currently employed at a national laboratory in the United States, Lawrence Berkeley National Laboratory, and I'm working as a computational astrophysics intern. And I'll tell you more about what that means in a little bit. And I actually just graduated from college in June, so class of 2020. I graduated from a small liberal arts college in Massachusetts called Williams College, and I was a double major in astrophysics and studio art. So I can also talk more about that. And I've lived in a couple different places, all in the United States. I think I lived in Hawaii the longest. I've also lived in Washington State, and I currently live in Massachusetts. And I saw a lot of people asking how I got into astrophysics or why, and I don't entirely know, but I think there were a couple influencing factors. The main one being both my parents are really nerdy. So my mom used to be a physicist, and my dad has always been an amateur astronomer. So I've been around telescopes since I was little, and Hawaii is a really great place for observing the night sky. And I guess in addition to that, I also really loved watching like science fiction things and documentaries about astronomy when I was little, including the Cosmos series by Carl Sagan. He's this really awesome astronomer, I guess maybe a little bit before our time, but he was just really great at explaining astronomy in an accessible way. And so I really loved all of his stuff. And I guess in general, since I was little, I've always been sort of questioning the universe and everything and trying to look for patterns. And I think those sorts of curiosities are really helpful for a career in astrophysics. So if you guys question everything around you, that's a nice skill to have, because astrophysics is trying to sort of explain and answer things around us. And since I've been in college and now graduated, I've worked on a pretty big variety of research projects in the field, including the study of exoplanets, which is like planets outside our solar system. I've worked on astroparticle physics, which is looking at how teeny tiny particles move around. I've studied galaxies, and I'm currently studying neutron stars, which are like the dense leftovers when a star that's really massive explodes. And this picture is of me when I worked at CERN, which is a particle accelerator in Europe. So I guess I just wanted to give a little bit of description of what my high school years were like, because I know a lot of people here are in high school or around that age. So when I was in high school, I definitely really loved math. I think I loved math more than any real science discipline. I was really just into math. So I took as many math classes as I could. And then I took a physics course, I think in my senior year of high school. And that was really my first introduction to physics, but I'd been taking math for a long time. And I think for me, the biggest thing that made me know I wanted to do astrophysics, well, there were a couple things, but one of the big ones was I got to take calculus, which is this really cool form of math that you definitely use a lot as a physicist or an astronomer. So I think I'd recommend for anyone entering high school or in high school, if you have the ability to take calculus, that is fantastic. Definitely take it if you can. And if you can do well in these sorts of classes, that's a really great way to show your interest in STEM and astrophysics to colleges, for example. And so in addition to these classes, I also I think I tried to be well-rounded during my high school years. So I took a lot of art classes, and actually most of my extracurriculars were in art. I didn't do very much science stuff. I was just very enjoying the art side. And I also played sports, so I did tennis all 4 years of high school. And I think being well-rounded was also sort of a positive for when I was applying to colleges. And then I was lucky to also be able to take an astronomy course in high school, which I know is definitely not normal. That's like not a very common high school course offering. But again, if your school offers it, that can be a really great way to, you know, get involved in astrophysics and also show colleges that you're interested in the field. And then I also got to attend a conference, which is where professional astrophysicists and astronomers go and present their work that they're researching and talk to other professionals and students about what they're doing and collaborate. So it's a really fun environment. And that's also a place, if there's any conferences offered in your area, that can be an opportunity to sort of see what's going on in the field. And I guess the other thing I did finally was I tried to find online resources for learning about astrophysics. And so there's these really cool things called citizen science projects, which are basically designed to involve the general public in science research. And there's a couple that are specifically for astrophysics research. So I'll put some links to websites where you can find those at the end of the talk. And when I was looking for colleges as I was finishing up high school, I think one big question that most people need to consider, especially if you're in the US, is whether you want to go to a liberal arts college or a research university. And so the liberal arts is usually a lot smaller and usually focuses on a more well-rounded education, whereas the research universities can be pretty big and usually encourage you to specialize in like one discipline. So for me, when I was looking for colleges, I wanted to go somewhere on the smaller side, but that also had a strong physics and astronomy department. And I specifically tried to find a department that had female advisors in it who could be mentors for me, and also a department that would definitely emphasize support for their undergraduates and allow me to pursue my interest in art as well as the astrophysics. So for all those reasons, I ended up going to a liberal arts college, but I think that a lot of people could also be very well suited to research universities. So both have a lot of strengths. And so just to summarize what I'm going to talk about for the rest of this talk, I'll start off by talking about what astrophysics is, because it's sort of a funny name, and I don't think it's sort of confusing. What is this field? And then after that, I'll talk about where can astrophysicists work. There's actually a lot of different places. And then thinking about what's actually needed to become an astrophysicist, or what are some skills that are useful to have. Looking at if there is any diversity in astrophysics, because it's sort of shaky. It's not a very diverse field, but maybe things are changing. And then finally, looking at how can you guys get involved in astrophysics. So I guess I just wanted to try a brief brainstorm to see if you guys can think of anything that astrophysicists might do or study. And these are some examples that you can sort of use for reference. And you're welcome to type in the chat if you have any ideas. Let's see if I can actually access the chat. Or maybe Sarah, if you see any, I don't know how to access the chat from here, but if you see any.
I'll let you know if there's any answers right now. Come on, guys. You know I can, you can do it. Oh, can you can't? Oh, the stars, planetary motion.
Oh, yes.
Ooh. We got some pretty good answers.
Yeah, these are great. So yeah, all of those and a lot more too. So let's see what else does astrophysics do? So there's actually a lot of different fields within astrophysics, and they all sort of explore different topics. But yeah, if you guys said planets or atoms, those are all included. So I'll talk about each of the subfields just to give you guys an idea of what's out there. So there are four, I sort of divided into four categories. So there's observational and experimental astrophysics, and those are sort of connected to each other, which is why I put them closer to each other. And then on the other side, there's theoretical and computational astrophysics. And I'm a computational astrophysicist right now, but I've sort of dabbled in all four, so I can talk about each one. So the observational side of things is probably what most people are, I think, most familiar with, and it involves telescopes, a lot of telescopes. And usually these telescopes are either on Earth or in space, like the Hubble telescope here. And they are really, really useful for us because they allow us to observe the universe, not just with our eyes. So they can help us look at things from other parts of the spectrum of light beyond what we can see, so beyond the visible part of the spectrum. So it really gives us different perspectives on the universe. And yeah, so these telescopes are used to take images of things like, I think this is a fuzzy galaxy on the upper right. And they're really helpful because they can resolve things beyond what we could normally see. So it's like very refined images that we wouldn't be able to observe otherwise. And they can also produce images with like lots of different colors that allow us to sort of study different features of the objects we're looking at. So observational astrophysics is all about looking at things from different parts, using light in different ways, and trying to figure out what's going on. So it's really fun. And here are some examples of things that observational astrophysics has uncovered recently. I hope you guys are familiar with the black hole image that came out not too long ago. That was super exciting. The first time a black hole had ever been directly imaged. And yeah, I think that was big news all over the world. And then also pretty recently, there was a comet that passed by pretty close to Earth. And so a lot of astronomers and amateur astronomers were able to take images of that comet using telescopes. And then also very recently, they discovered the first planets orbiting around a star that's really similar to our sun. So that's super exciting because these are planets that could potentially, host life, or we could inhabit someday, who knows? So these are all some of the, I guess, cutting edge observational capabilities. And then connected to that is experimental astrophysics, which is not just using the telescopes, but designing telescopes. So if you like working with things with your hands, this is a really great subfield of astrophysics. So it's all about designing instrumentation. And here are some big examples of instruments that are currently used by astrophysicists. So this is CERN, where I worked on the left. And that's, like I said, they accelerate particles. So they loop them around this big machine, and then they go really, really fast, and then they collide with each other, and scientists will look at what happens when the particles collide. And then on the upper right, we have Arecibo Observatory, which is this huge dish in the ground, and it collects light from the radio part of the spectrum, which is something we can't normally see. And then on the bottom right, we have the two Keck observatories, which are on the top of a giant mountain in Hawaii. And they're contributing to science in a bunch of different ways. They're really useful telescopes. These are just a couple examples of recent experimental developments. On the left, we have the James Webb Space Telescope, which is in development right now. And astronomers and astrophysicists are really excited for it. We're just like waiting for it to be launched into space. We think that it will be as useful or more useful than the Hubble Space Telescope, which is also like one of the most important telescopes ever made. And then on the right, we have the LIGO instrument, which detected gravitational waves for the first time, I think within the past couple of years. And that was like a huge discovery that's basically allowing us to observe the universe in a whole new way. So that's, I think, located in rural Washington state, but it's really large. And then so on the other side of things, there's the theorists, or the theoretical astrophysics, which, as you can see here, involves a lot of math. There's a lot of math equations because basically they use math as their language. Math is how they're explaining all the science that's being observed by the observationalists. So trying to really justify what we're seeing in the universe with math equations and looking for patterns. So it's a really helpful side of astrophysics because it's sort of questioning everything and thinking about how we can explain it. And this is just an example on the upper left of modeling how objects' light emissions vary with its temperature. And you can basically write a mathematical equation to determine what sorts of light is coming out of an object based on its temperature. So that's really helpful for studying things like stars, which can vary a lot in what sort of light they're emitting and what temperature they're at. And then connected to theory is the computational astrophysics. So that's what I'm working on right now. And basically, I guess as the name describes, it uses computers a lot, and coding especially. So there's a lot of code, and also you might be working with things like supercomputers, which are really cool, big clusters of computers that can run really intense simulations and computations. So computational astrophysics also uses a lot of math like theory, and I think theory now is really merging with computational astrophysics because it's getting to the point where the math alone is too much for human brains to sort of analyze, and so you really have to harness computers to sort of analyze things fully now. And this is an example of a really cool simulation of a black hole on the bottom left that's spinning and spinning material around it. And it looks sort of similar to that image I showed a couple slides ago. So I think one of the nice things about theory and computation is that it's supposed to be able to reproduce and describe what we're seeing. So those are the four, I guess, subcategories of astrophysics, and each one is really important. Now I want to talk about what the average day of an astrophysicist is like. And so usually it involves sitting next to computers for a decent part of the day. So that's what the upper right picture is supposed to show. Usually you're sitting with other people who are your colleagues, and you're talking to each other and collaborating about what you're studying and how you can fix things like your code or your math. And you might be working at a place like a university if you're a student or a professor. Or you could be at, an observatory or a government lab. So there's a lot of different locations that you might be at. And then usually when you're not working on your research or your projects, you'll be communicating science in some way. So you might be traveling to a conference to present your most recent work, or you might be working on a paper that you're going to publish to present your findings. So there are like a couple journals that are really important in the field of astrophysics, and they publish all the research from scientists. So things like the Astrophysical Journal, for example. And then if you're an observational astronomer, you'll also probably be traveling around to telescopes, which is, I think, a really fun part of the job. You get to visit some of the really big telescopes and use them to observe things that you're interested in. So on the bottom left is an example of me at a telescope on the top of a mountain in New Mexico. Okay, let's try another brainstorm. So if you were an astrophysicist, do you have any ideas about where you might work? I think I've mentioned a couple already, but let's just see, maybe, Sarah, if you see any of the comments, if anyone has any ideas. There are a couple different places.
Oh, we got some good answers already. So fast.
Okay.
SpaceX, NASA.
Yes, those are good ones. Yeah, I tried to draw the NASA logo on this slide just for fun. Yeah, NASA is great. I would love to work at NASA someday. That's like one of my dreams. So yeah, there's like a bunch of different places, and NASA is a really good example. I think one of the main ones, and NASA is included in this, is an observatory. So that's a place that has telescopes available at it where you can use them and conduct your research. And observatories usually have a salary. If you've just gotten a PhD and you're starting a job at an observatory, the salary is probably around 80,000 US dollars a year, which is pretty good. So you're starting off well. And then similarly, you could also work as a professor or a research scientist at a university. And these ones also have a similar starting salary of like 80,000 a year for people with PhDs coming in. And then NASA is also an example of a government lab. So these are, funded by the government in order for people to conduct research. Usually it's sort of in specialized areas that are of interest to the government. So for example, I'm working at a government funded lab right now, and they're very interested in explosive events in astrophysics. So they're really funding a lot of that, as well as they're funding the use of supercomputers. So those are two areas of interest. And these salaries can be even higher. So they might be starting at, upwards of 100,000 a year. They pay well. And then finally, SpaceX is an example of a tech company which also pays quite well. And usually if you're working for a tech company, you might not be doing as much of the science research side of things, but you'll probably be doing a lot of instrumentation. So building things, whether it's telescopes or some other machinery, you could be working on a rocket ship to go into space. So there's a lot of options there. I think, did I have one more? Oh yeah, okay. The other one, which I just wanted to put for fun, is consulting firms, which I didn't really know what they were too well, but they're basically places that help people manage their money. So they're not really directly involving the astrophysics science, but they really value people with math skills and computer skills. And so they actively recruit people from physics and astronomy to come and, analyze data sets and look for patterns in like money matters. And they also pay quite well. So if you're interested in that, that's also a really good option. And then beyond all those different astrophysics organizations, there's also a lot of other fields that you can go into and sort of apply astrophysics. So I've done a lot of space-themed art, which is, I think, actually more common than I had thought when I started doing it, but it's really fun because you can kind of visualize the science that you're doing in different ways, and they really, I think, work well together. And then you can also go into another STEM field and sort of combine it with astrophysics or astronomy. I guess one example would be astrobiology. So that can be really helpful if you're sort of looking for life on another planet. You might get to use both astronomy and biology. I think they actually just announced a couple days ago that they found some signatures of life on Venus, maybe. So that's really interesting. And then there's also engineering, like I mentioned before. You could be working on rocket designs or a whole bunch of different stuff, and it uses astrophysics for sure. And then also there's space law or space policy, because the governments of the world are actually regulating how space is sort of used and perceived and who can do what in space. So you can work on the policy side of things. And then there's also philosophy of science, which is a subset of philosophy that's sort of using physics to interpret the universe and our place in it from a philosophical perspective. So that's also really cool. Okay, this is sort of a quiz, but it's okay if no one gets any of them right. These are 4 examples of female astrophysicists who have contributed to the field, and I was wondering if anyone recognizes any of them. It's kind of difficult, so if you recognize them, feel free to put their name in the chat, but no worries if no one gets any. Give it like a couple seconds.
You got some answers already. When it was
Wow.
Vera Rubin, Catherine Johnson's. Yeah.
These are great. I'm so impressed. Wow.
Our community, dude.
Wow. Yes. Okay. So here are the answers. So yes to Catherine Johnson and Vera Rubin. Great job. So on the far left, I'll just introduce them in order. We have Annie Jump Cannon, who developed an original method for classifying stars based on their physical properties. And so that's from like observational astrophysics. And her method for star classification is still used to this day. So if you take any introductory astronomy or astrophysics course, you'll probably learn about this method. It's really important. And then the next one is, like you guys guessed, Catherine Johnson. You might know her from the movie Hidden Figures, which came out a couple years ago. And so she was this amazing woman who contributed calculations, so a lot of math, for sending astronauts into orbit around Earth for the first time. And she also contributed calculations for sending astronauts to the moon for the first time. So she was awarded the Presidential Medal of Freedom for her work And I think she passed away not too long ago, but she was really amazing. And then, yeah, Vera Rubin was an observational astronomer. She observed the rotations of galaxies like the one you see behind me. And so from looking at how fast galaxies were rotating, she realized that there must be some sort of matter in the galaxies that we weren't seeing. And so that's actually called dark matter now. It's called dark, I think, because we still haven't seen it, but we know it's there. So that's actually one of the things that astrophysicists are trying to explain even now. And then finally we have Jocelyn Bell Burnell. I think she is still alive, so that's cool. She's not too old. And she actually discovered these really cool radio pulses that were being emitted from what we now know to be neutron stars. So that's actually what I'm studying right now. So she found these neutron stars were spinning really, really quickly and emitting beams of light towards us as they were spinning. And they're now known as pulsars, so they have their own name. And so for this discovery, she was awarded the $3 million Breakthrough Prize, which is a huge amount of money. I mean, more than any other award I can think of for STEM fields. And so she said that she wants to use all this money to promote diversity in the STEM fields and encourage more women to enter the fields. So that's really awesome. And so these women are kind of hard to recognize, I think, partially because women have been so underrepresented in the field of astrophysics for a very long time. And I think it's still true to this day. This is a plot showing percent of bachelor's degrees earned by women in selected STEM fields from the 80s to basically now, 2016. And I guess the main things to note here are the red line is 50%, so that means half of all bachelors are going to women, so it's like gender parity. And the purple line is labeled for astronomy degrees, and the line in green at the very bottom is physics degrees. And as you can see, astronomy never really went above 40% of degrees to women. Around 2016, it was closer to 30%, so it went down. And physics degrees have stayed pretty consistently at around 20%. So in both fields, astronomy and physics, women are definitely underrepresented compared to most other STEM fields. And so that's a problem. We would like to fix this because it's important to have as many perspectives in the field of astrophysics as possible if we want to, discover more things and get more ideas. You want to have a diverse array of people working on everything. So we want to know how to get involved. How do we, increase the representation of women in the field and contribute? So I was going to give you guys some ideas for things you could work on if you come into the field. These are some big questions that astrophysics has yet to answer. On the far left, this is my little doodle of a galaxy. And like I mentioned before, we know there's this stuff in the galaxy that we can't see called dark matter. So we'd like to be able to detect it and explain why it's there and why we can't see it very well. So that's a really big research problem in the field right now. And then next on the right, I have a little illustration of the evolution of the universe from the Big Bang to basically now where the galaxies are. And there's a whole field of astrophysics studying the progression of our universe from where it started. And we don't really know how it started or what it was like in the early times. So that's something that we would like to, understand better from both simulations and modeling as well as observations, because we can actually observe things that are really far away as well as sort of looking back in time. That's like a interesting feature of observations. So you could actually look back and see what things were like in the early times of the universe and try to figure out how it was different and how did it lead to where we are now. And then as well, we're also interested in why the universe is expanding, because I think a couple different scientists have noticed that things are moving away from us at faster and faster rates. So if you were to continue that, at a certain point, we wouldn't even be able to see anything in the night sky because everything would be too far away. So that's really scary to think about, and we'd like to know why this is happening. I think scientists have come up with this dark energy explanation, but we don't know what dark energy is. We just think that it's pushing everything apart from everything else. So that's a really big question as well. And then on the bottom right, we're looking at planets. That's a really active field right now. We want to find more planets, always looking for more planets with new telescopes, as well as trying to figure out if there's planets that could host life. We want to know if there's other alien species out there, as well as whether or not there's any planets that we could move to in the future. So you could work on looking for planets if you wanted. And then on the bottom left, I did a little illustration of, I hope it looks like a black hole. And black holes are super confusing to everyone. They're these mysterious dark objects that no light can escape from, but we know they're really massive. And so we'd like to understand better what's going on around black holes as well as inside black holes. So that's a very active field as well. And these are just some examples of topics, so I can give even more ideas if anyone's interested after the talk. So for you guys, if you're in high school, there are a couple different things that you could do if you wanted to get more involved in the field. I think the first one is probably the easiest, and that's to check if you have any local astronomy clubs in your area. So that could be from, a school that has a club, or just like adults that gather to observe the night sky. So you're always welcome to go to things like that. Usually astronomers love to talk about science to other people, so you should feel welcome. And I think the link I put down here can help you search. If you live in the US, you can type in your area and it will tell you if there's any clubs in your area. I did one of those when I was in high school, and I always thought it was really fun. And then the next thing you can look for is summer camps. So these are sort of like a taste of what research is like in the field. And they're usually geared towards high school students, I think. So if you participate in a summer camp, I think it's usually around 10 weeks maybe during the summer. And you'll be with other students or other young people who are also enthusiastic about astronomy and physics. And hopefully you'll get to do some research or meet professionals who can tell you more about the field and how you can get involved. So that's really fun. And then similar to that, you could also look for volunteer projects or research internships that could be either paid or unpaid. And for looking for these sorts of opportunities, it can be helpful to check out local universities, any universities in your area, because they're usually the places that have the resources to, bring in astrophysicists and do research, and they might be happy to, host students. And if you're in college, there's a lot of things that you can do. So I'll just go through some of them. And this is mainly geared towards US students, but I think similar opportunities exist abroad as well. So in the US, there's a whole group of research opportunities called Research Experiences for Undergraduates, or REUs for short. And these are also during the summer for 10 weeks. And they're funded through the National Science Foundation, which is, I think, one of the main funding sources for astrophysics in the United States. And so these will give you the opportunity to focus solely on research for 10 weeks with an advisor who is, probably teaching at a university or working in an observatory. And so it's really a helpful experience, and you might even publish a paper or present at a conference if you participate in this sort of opportunity. I just wanted to highlight one example called the Banneker Institute, which is, I think, at Harvard, and it's specifically geared towards underrepresented minorities in STEM. So they're really trying to increase diversity in the field. And there's just like opportunities all over the United States, I think. So there's different things to choose from, and you can pick based on either the research that you're interested in or the location. So yeah, I have a bunch of links at the end of this talk for our research experiences, so I'll point you guys to those too. And then besides REUs, there's also other internships that are usually university specific, and they have similar offerings. So these can be less competitive, I think, than the official REUs, so they're good to consider as well. And beyond summer internships, you can also look for study abroad opportunities. I did a study abroad in my junior spring in college, and I went to Geneva in Switzerland, and that's where the CERN particle collider is. So I got to work there. So that was a really great program, I think offered through Boston University, and they let you both conduct research and take classes. So it's really useful if you're looking to get, college course credit while you're studying abroad and doing research. And then you can also look for volunteer projects as well, again, offered through universities probably. And I think the main goal, if you're in college wanting to do astrophysics, is to try your very best to present your work. If you do any research, try to present it in some way, either at a conference or through a paper that you publish, with your research group. I think that if you're looking to go into astrophysics as an advanced degree for like a PhD, for example, the graduate programs really look for evidence that you have been communicating your work and presenting it to others. So that's very important. And so these are just, I'm going to go through some general tips I have for becoming an astrophysicist. I had a hard time picking just 4 because there's like a lot of different things that you can do, and there's really no one right answer, but I think that these 4 are probably the most important ones. So the one on the far right is research. So like I said, if you can publish or present work that you've done while you're in college or even high school, that's fantastic. And it really shows that you're interested in the field for, potential employers or graduate programs. They love to see that you've done things, that you're interested. And it can also just be a great way to sort of figure out what part of astrophysics do you want to work on. I mean, I've done projects in a lot of different fields, and I think now I know I want to work on high energy astrophysics, but there's a lot of different things that you might think you like, but until you've tried it out in research, you might not really know if it's for you. And then connected to that, I think it's also important to look for mentors in the field of astrophysics. So like I mentioned, when I was applying to colleges, I tried to find places that had female advisors who could be mentors for me. And I ended up, I think, only working with women advisors all 4 years of college, which is pretty impressive considering how few women there are in the field. But I think that it was really valuable to have them as people to look up to and, see people who look similar to me, to know that I can do this. So that's really important, I think, going into the field where it's mainly men. So it's nice to have people to support you. And they can also sort of guide you and give you advice on how to go about being an astrophysicist. And and then so also I think it's important if you're in high school especially, but also in college, try to take all the math and physics classes that you can. Whatever's offered, take it. If you're really enjoying it and there's, graduate courses being offered anywhere, you can take those. So however you can, take all the math and physics. And then if there's a bonus of computer science offered at your high school or college, try to take that as well, because I think astrophysics is really dependent on computers now. So it's nice to have some familiarity with computers and coding. But I didn't actually take any computer science when I was in high school. So you can also do that later, it's okay. But math and physics for sure. And then I think the last thing that I want to emphasize is just some important skills and, I guess qualities to have as you try to become an astrophysicist. I think creativity is really important. So just trying to think about things from multiple perspectives and, having an open mind can be really important for studying the universe and, trying to answer questions that haven't been answered before. And I think connected to that, it's also important to be enthusiastic about what you're doing. So if you're doing research and you're not enjoying it, that probably means you should try something else in the field or shift your focus. And then finally, communication, I think, is really crucial. So that can be in the form of presenting your work. You want to be able to clearly talk about what you're doing in a paper or, in a conference presentation, as well as I think astrophysics really values public outreach. So if you do become an astrophysicist, it's important to be able to describe what you're doing to the general public. We want to encourage everyone to be interested in the field. So we want to make sure that we're conveying the science in a way that makes sense to everyone and, you know, encourages everyone to be interested. And I think that's a quality that graduate programs really value as well, the ability to communicate what you're doing clearly. So all of those things are very important, which is why they're all sort of orbiting as planets around the field of astrophysics. And I wanted to show you guys some examples. Even though women are not well represented in the field, there are some really awesome women working right now. And so these women are all astrophysicists working on a lot of different problems. I think some of them are working at NASA, some of them are at universities, and they're all, you know, contributing and really great. And they can be mentors to our generation as well. So these are just some examples. And yeah, you could be next. I feel like I could end up working with any of you guys in a couple of years. Who knows? We might see each other at a conference. And then finally, I have a couple pages of links to important information that I don't want to talk a whole lot about right now, so I can get to your questions. But feel free to look back at these. I think that these slides will be shared with you guys, so you can refer to these later if you have any other questions or want more details. So I have a slide on astrophysics schools, so colleges and graduate schools. I've got another slide on internships and opportunities for research. This is for both high school and college, as well as scholarships. So there are some STEM-specific scholarships and physics-specific scholarships that you might apply for. And then this is a link just talking about different interdisciplinary astrophysics options. So some examples of art, space law, space astrobiology, or engineering or philosophy, if you're interested in any of those. And then these are some of the things I mentioned on websites that you can look to do research if you just want to get some experience with what astrophysics research is like. So citizen science projects, some of these websites are really great for that, as well as just giving examples of what people are doing in sort of a summary format. I have, I think, a link to NASA, a couple NASA links. NASA's great. So you can explore all of these. And then this is some examples of my art. If anyone wants to do space art, let me know. And you can look at these for examples, but I just love it. It's so fun. And so with that, I'm happy to take anyone's questions. Let's see if I can look at the chat now, because that would be helpful.
Are you able to see the chat, or do you
Yes, I see the chat now.
Okay. I see some questions already. There was a question before. So I don't know if you can go back and see it.
Yes. Okay. So, oh, I see someone asking, did an anti-jump cannon use spectroscopy? Yes. So spectroscopy is really useful for looking at stars and trying to figure out their properties, things like their temperature. So yeah, spectroscopy. Yes. Okay, I see more questions. Okay, whoever has to go, I'm glad you could come. Thank you. And so I see a couple questions. Do you need astrophysics to be a rocket scientist or space elevator engineer? Ooh, I think that the answer depends. So if you really want to be on the engineering side of things, I don't think you necessarily need an astrophysics degree. I think engineering is probably the way to go, but it can be really useful to have astronomy course background, because I think that's always something that's valued even in the engineering fields, or in rocket science, for example. Oh, okay, next question. Can you talk a little bit about cosmology? Yes, so I had that slide showing all the different big questions that haven't been answered in the field. And there was one little picture I drew of the Big Bang and then the progression of the universe since the Big Bang. And that's actually basically the field of cosmology, is sort of looking at how our universe has evolved from this bang to where we are now. So cosmology is trying to explain, yeah, how did galaxies form? What's all the stuff in our universe? How did it get there? And why is the universe, expanding? All of that falls into the field of cosmology. So it's sort of looking, I think, at the big picture, really, in astrophysics. Okay, another question. Ooh, who do you work with daily? So I'm right now in sort of a weird position because I'm working as a computational astrophysicist. So I'm actually in a computation division at my research lab. So I'm not in an astronomy department. So I'm actually working with a lot of computer scientists, people that mainly work with computers. They might not even have formal astrophysics training, but the thing we share in common is that we're using computers as tools. So you might end up working with people that aren't necessarily astronomers, but all share an interest in sort of studying science using computers. But I've also definitely had times where I was working with both astronomers and physicists. I think that's really common. You might be with astrophysicists or people that are just physicists or just astronomers. It's all very connected. Okay. Oh, do you know of any places where high schoolers could job shadow or get a fellowship with astrophysics? So I don't know. I think it depends on your location, but I would say in the page I provided on internship links at the end, there's a list that is specifically geared towards high schoolers. And I think a lot of the places on that list are universities that host high schoolers for things like summer camps. So I would say that's probably a great place to start. And usually in those sorts of camps or internships, you will be working with professional astrophysicists. So that can be really helpful. Next question. What information, like math theories or coding languages, do you use on a daily basis? So I code in Python, which is, I think, a newer coding language. I kind of learned it on the fly while I was conducting research, so I never took a formal coding class or computer science class. I would recommend that now. Like, I took the harder path, but you can definitely do it just sort of learning coding on your own. So yeah, I use a lot of Python as well as C++, which is another coding language. And as far as math, I use a lot of calculus, which is why I love calculus so much. I think it's great. And I think besides calculus, just like algebra, the basic math stuffs. And in terms of physics, I'm using a lot of thermodynamics, which is studying like temperature dependence and how gases move, as well as things like fluid dynamics, which is how fluids move around. So there's a lot of different subfields of physics that can be really useful. Oh, speak more about space policy. Yeah, I can talk about that. So, so governments basically regulate how space is controlled around Earth. This is like near Earth, basically. So it's only kind of the region where you might put satellites, for example, or launch missiles that go into space. So the near space is regulated sort of, I think, similarly to how you regulate the oceans, so like maritime law. So it's sort of, I don't know, it's sort of chaotic, honestly. It's not really controlled by any one government, but there's a lot of policy involved in regulating how you can send things into space or travel through space. And then there's also, I think, regulations on things like exploring asteroids. Like if you were to land on an asteroid and take things from it, there's regulations on how you can do that. So it's a really cool field that I think is sort of developing now, even because we're exploring space more than we have ever have before. And it involves a lot of law for sure. So if you could get a law degree and then, apply astrophysics with that if you wanted to. Okay, let's see, which one should I pick? Oh, do you have any mentorship programs that you would recommend that are physics related? So I think, I'm assuming this is like for research, if you wanted to go into a research program that's physics related. So I think, again, I would point to the list of internships that I linked at the end of this presentation, which I think will be shared. And that's gonna have examples of places that I think usually offer both astronomy and physics research. So if you wanted to do something more on the physics side, there should definitely be options for that as well. I think actually physics is probably more widely available than astrophysics or astronomy research, just because it's a larger field and it's more funded, I think, in general. So you can definitely get physics opportunities, whether you're in high school or in college, especially in college, though. Yeah. Ooh, okay, one more question. Could you explain a little bit about how having a cosmic perspective helps solve big questions? Ooh, okay. So yes. So I think that it's important to think about how everything is connected. So in that sense, I think I'm interpreting cosmic perspective as like thinking about how everything works together in the universe and how are things sort of influencing each other. I think that's a really useful perspective to have when you're thinking about how to answer some of the big questions. Because, for example, if you're looking at cosmology, we think that stars formed before galaxies. So some of the early universe times you would only see individual stars floating around. And then now you have to think about, well, how did galaxies form from that? So we think maybe stars started to group together in clusters and then eventually form galaxies. So I guess that's an example of where you kind of have to think about things as they relate to each other and not just individually. And it's really just like all connected in a big picture, which is pretty cool. Okay. Do we have time for a couple more questions?
Yes, we actually have around 5 minutes. So last question from Sporty. Sporty,
Okay,
I
good.
hope I'm pronouncing that correctly.
Yeah. So, okay, I heard this thing about how you can create a black hole using a sound of more than 1,000 decibels. Is this true? I don't know. That's crazy. I don't know what this means. I don't know if this is saying you just make a really loud sound and then that creates a black hole. I'd have to research more about that because I don't know. But I do know that there's this idea that black holes might exist on really tiny scales. So not just like on a huge galaxy size scale, but there might actually be black holes that we can't even see because they're so small. So that's actually in the field of quantum physics. So we think that they might just be sort of spontaneously popping in and out of existence all around us, but in such a small scale that they don't really influence anything or can't be observed. So I just thought that was really cool. But now I need to learn about this thing with sound because I don't know.
Is
Good
there any
question.
more questions, you guys?
Yeah.
You guys have been killing it so far.
Yeah, this is great. And we should definitely share these slides because they have like all these links to research
Yes, this
options.
will be, this is recorded and it will be posted in the Girl Genius YouTube channel. So for any.
Okay, good. Yay. Yeah, research is important. I want to
Yes.
know where the research is. And I apologize I can't provide more info on international research opportunities. I think I'm most familiar with the US, but I think that the options are probably similar internationally as well, just maybe through different, names. The places are different, or the funding sources might be different. But yeah.
Next time you'll provide us with more international resources.
Yeah, I gotta do more research myself.
Yes. All right. So I feel like there's no more questions.
Yeah,
So
we've had a
thank
lot.
you so much for coming, Nicole. We all loved it. There were so many questions, as you can see, and everybody was super excited to learn about astrophysics. And just thank you so much for taking the time for us to learn about this world that you're in. And yeah, thank
Thank
you
you. I'll
everybody
put
for coming to this workshop.
I'll put my art slide up again so you can look at my
Yes,
art.
your art is amazing. We love it. So creative. Alrighty. So, as you can see, everybody loved it.
I'm so glad. I honestly, like when I was in high school, I I had to navigate a lot on my own. So I think that it's nice to have some information shared with you so that you're not having to discover as much on your
As
own.
a high school senior, I totally tell you that this was so informative, and like I really want to get into cosmology. Is that what it's called? Sorry.
Yeah,
Yeah,
cosmology.
I love it. I don't know. I'll have to research into that.
It's very cool.
Alrighty, you guys. So I think it's time, just about to be time. And
Mhm.
yeah, thank you so much for coming. As I said, I hope you guys enjoy. And be sure to not miss next week the intro to UX and Figma. If you guys have not signed up for that, be sure to do so. And follow us on social media, as well as join the community on Slack. And yeah, that's pretty much it from our side, and we'll see you guys in the next one.